Today, folks, we are going to start Unit 3. So, Unit 3, Section 1, which in your textbook is Chapter 6.1, we are going to take a look at how to identify and evaluate, add, and subtract polynomials. We are also going to look at classifying and graphing polynomials as well. And when you're all done today, you're going to be able to add problems such as this, polynomials such as this. Now, our WIC or know and do today, we are going to look at the word term, and we're going to look at what term is. What is that word? And we're going to link also something with the word term. So just to give you an idea, go ahead, pause this, write this down. Our essential question today is, what is adding like terms? Okay, so let's talk a second about a term. Sometimes a term, as you know, is could be a time period. For example, a semester could be a term. Now, if you're in a term and a friend is in a term and you're both talking about the same time period, then your time periods are the same because you're in like terms, like fall semester. Likewise, a term in mathematics is much the same. For example, if I have 2x cubed and an x cubed right there, okay, those are called like terms. Why? Because they have x to the third and x to the third. And then we're going to do things like add like terms, subtract like terms, so on and so forth. Okay, well, let's go ahead and begin with the lesson. Today we're going to start with a monomial. What is a monomial? Now, a monomial is a number or a product of numbers and variables with whole number exponents. Okay? For example, this here is a monomial right there. If I just take a look at just that one there, that is a monomial. Why? Because it has one term in it. Okay? Now, a polynomial can be a monomial or it can be the sum or difference of monomials. So if I link some together, then that gives me what is called a polynomial. But remember, a polynomial can still be a monomial. Okay? So, for example, look over here. These are polynomials. See? This is a polynomial. It has how many terms? Well, there's one term there, one term there. So there's two terms, so that's a polynomial. This here is a monomial. Why? Well, it's 0.15 x, and it's a whole number exponent. Okay, here's another, this one right here. That is a monomial, but it's also a polynomial as well. Look at this one. I have two terms. This is not a monomial, but it is a polynomial. Okay. All right. Now these are examples of things that are not. You can't have x as a power. That is not a polynomial. You can't have the absolute value of a polynomial. That is not a polynomial. You can't divide by a variable. That is not a polynomial. And over here, notice I don't have a whole number exponent. That is not a polynomial. Now, next we're going to take a look at the degree of a monomial. The degree of a monomial is simply the sum of the exponents of the variable. So, in other words, all we're going to do is we're going to add up, and we're going to show examples. So we're going to add up the exponents of a monomial, and that gives us the degree of that monomial. And we're going to show that here on the next slide. Okay, go ahead and pause this and make sure you get down each of these definitions in your notes. In this slide, we're going to identify the degree of each of these monomials. So I have z to the 6. So identify first of all the 6. And now, what is this? Well, right here, folks, we could say it's a 6th degree monomial. Okay? So why is it a 6th degree? Well, there is only one exponent, which is 6. So, you know, if it had two of them, then we would add them together. Okay, the next one. If I give you a plain old number. Now, if I give you a plain old number, remember that's the same as 5.6 times x raised to the 0 power. Okay, now, that is a monomial, but what is the degree? Well, what is your degree of your exponent here? Well, your degree is 0. So that is a degree of 0 for that monomial. Okay, now let's take a look at this one here. I have 8xy cubed. Now, remember, this x is x to the first. So if you don't see an exponent, it's to the first power. Y to the third. So here's a monomial, because remember, a monomial is the product of numbers and variables all pushed together. Okay, so Now, we're going to add up the 1 plus the 3. 1 plus 3 is, you said it, it's going to be 4. So that is a 4th degree monomial. Okay, let's take a look at this next one here. On this next one, I have a squared b c cubed. Now remember, b you don't see a power, so put a power there. So it's 2 plus 1 plus 3. So that makes it a 6th degree monomial. Okay, so there you go. All right, let's move on. Next, we're going to take a look at the degree of a polynomial. So first of all, you're going to list, well, first of all, find the degree of each term. And then after you find the degree of each term, then you're going to put it in descending order. Okay, so here's your definition. This is a polynomial is given by the terms with the greatest degree. Now, let's go down here and see what that means. I have a polynomial here, and I have how many terms? Well, 1, 2, 3, and 4. Okay, so there's 4 terms. What's the degree of this one? Well, the degree of the first one, I only see a 3, so it is a 3. What's the degree of 8x to the second? Well, there's only one variable there, only one exponent, so it's going to be a 2nd degree term. Okay, what about the third one? Well, it's x. Remember, there's a little 1 there. Okay, so you can put your little, 1 right there. So it's x to the first power. So if you have x to the first power, that means that's going to be a 1st degree term. Okay, and of course, looking at this number, that's just a number, and we found out before that if you had just a number, that was the same as having, say, x to the 0 power, which means it was a degree of what? Well, that would be a degree of 0. Now, we're going to put this in descending order, just like we did last semester. So, in descending order, we're going to put this one first because it has a degree of 3, this one second, degree of 2, this one third, degree of 1, this one last, degree of 0. So, it's in descending order. Okay, now, what is the degree of this polynomial? What is the degree of the term in the front? By the way, the degree in the front is called the leading term. Okay, so you might want to write that off to the edge on the left side in the notes section of your Cornell notes. You're going to call it the leading term. So when I refer to the leading term, I'm talking about the term that's out front after you put it in descending order. Now, if you take a look at that term, the degree of that term is the degree of the polynomial. That's what I put right here. That is the degree of the polynomial. And the number in front of that term is called the leading coefficient. Okay, so make sure you get each of these definitions down in your notes. Okay, now a polynomial, right here, a polynomial can be classified in 2 ways. The first is by the number of terms that it has. Okay, and the second is by its degree. Okay, so again, a polynomial can be classified 2 ways, by the number of terms that it has and by its degree. Now notice, there are 2 very popular number of terms for polynomials. One is called a binomial. Now remember, bino means 2, so that is a polynomial with 2 terms. And then you have a trinomial. Now tri means 3, so that is a polynomial with 3 terms. Now, usually anything above that, we just call a polynomial. So, if it has 1 term, monomial. 2 terms, binomial. 3 terms, trinomial. And if it has 4 or more terms, we just call it a polynomial. Now, in your textbook, you're going to see a chart much like the one shown right here. Now, looking at this chart, it gives you some names of polynomials. For example, if you have a 0 degree, okay, just a number, we call it a constant. If you have a 1st degree, now this is a binomial because it has 2 terms, it's a 1st degree polynomial, we call it a linear. Okay, it's a linear binomial. Okay, now if I have 3 terms, remember that's called a trinomial, and if it's x to the second, that means quadratic. Okay, kind of like when we had a sequence, we called it a quadratic sequence if it had a second difference. Okay, so that is a quadratic trinomial. That's its name. Now, what if the degree is 3? Well, a degree is 3. Now, notice I have 4 terms here, so we just call it a polynomial. If it is to the 3rd degree, we call it a cubic polynomial. If it's to the 4th power, we call it a quartic. Now, notice here 1, 2, 3, 4, 5 terms, so we just call it a polynomial. So this will be called a quartic polynomial. Now, what if it has a fifth degree? Fifth degree means quintic, okay? Kind of like quintuplets, okay? Quintic. And if it, now notice we have 1, 2, 3, 4, 5, 6 terms, so we call it a quintic polynomial. Okay, and that's all the higher we're going to go with this section. Okay, let's go ahead and practice here. Now, first of all, let's read the directions here. It says, rewrite each polynomial in standard form. Then identify the leading coefficient, the degree, and the number of terms. And then name the polynomial. Okay, so this is what we're doing here. So let's go ahead and look at this. First thing we need to do is I need to put it in descending order. So let's put it in descending order. When I put it in descending order, notice this is a degree of 2, this has a degree of 1, this has a degree of 0. So I'm going to, now make sure you take the sign in front of the term with it. So it's going to be negative 5x to the second plus a 4x plus a 3. Okay, so now let's compare and let's see how that looks. Did we get it correct? Yes, we did. Okay, now, secondly, we need to identify the leading coefficient. Now, remember the leading coefficient, we look at the leading term. And the leading coefficient is the number in front, and the degree of the polynomial is that 2 right up there. Okay, so our leading coefficient is going to be, yep, negative 5. The degree is going to be, if you said 2, you are correct. How many terms does it have? Well, let's see. 1, 2, 3. Notice the terms are separated, remember, by addition or subtraction. So it has 3 terms. Okay, so it's going to have 3 terms. And what do we call this? Well, remember, it's to the second degree. Second degree, look at your chart that you wrote down in your notes. It's going to be called a quadratic. It has 3 terms, so it's called a what? Yes, a trinomial. Okay, so we're going to call this a quadratic trinomial. All right, go ahead, pause this, make sure you have that down. Now we're going to take a look at how can I combine some of these polynomials. Now, when you're in Algebra 1, you may have learned how to do them vertically or horizontally or both. In this class, I'm mainly going to focus on horizontal. So we're going to learn to add and subtract polynomials horizontally. If you want to do it vertically, stack them on top of one another, you're welcome to do that. All right, let's go ahead and begin. Okay, when you first take a look at this, ask yourself, do I need these parentheses? What's out front of them? Well, there's just a plus here, and I don't see anything there, so it's just a 1. So do I need these parentheses, or can I just drop them? If you said drop them, you are correct. So we're just going to write 2x to the third plus a 9 minus an x. Notice that is not in descending order, but we're not going to rearrange them just yet. Then I have 5x to the second plus a 4 plus a 7x plus an x to the third power. Now, what I'm going to encourage you to do is I'm going to have you code them by doing little lines under each degreed term. Now, this is a degree 3 on that term. And look across here, do I see any other degree? Yes, I do right there. There's a third degree term right there. Now let's go to the second degree term. Okay, there's one right there. Is there any others? Nope, don't see it. Okay, how about a first degree term? You know what? I'm going to put 2 lines underneath this second degree term. For the third degree term, I'm going to put 3 of them. And I see there's going to be 3 there. And then I see I have some constants. So let's put 4 lines underneath the constants. Now that I have it all coded, I am going to add the like terms. So I have 2x to the third plus, and how many x to the thirds do I have there? Well, if it helps you, I have 1. Okay, so you can put a little 1 there to help you remember. So I have 3x to the thirds. Now, I'm going to cross them out as I go so I don't get them confused and try to add them twice. Okay, next I have a 5x to the second. So I'm going to go to this, I'm going to step down, and by doing this, it's going to end up in standard form. So I have plus a 5x to the second. Okay, let's cross that out. And then I have a negative 1x plus a 7x giving me plus a 6x. Okay, let's cross those 2 out. And then I'm going to have a 9 plus 4 giving me what? 13. And there it is. Now notice it is in standard form. So it's all ready to go. And let's see if we did it right. Look at that. We got it. Okay, let's go try a subtraction now. Okay, for the subtraction here, let's take a look here. What's out front of here? I don't see anything, so it's just a 1, so I can drop the parentheses there. So it's just going to be 3 minus 2x to the second. And what else do we have here? Well, let's see. I have a negative in front of here, so I need to distribute this negative inside to all three terms. So I'm going to show the little arches there, so that helps me remember. So it's going to be minus x to the second minus 6, and a negative times a negative gives me a plus x. Now we're going to code it just like we did before. So I have x squared, so I'm going to put one line underneath of it. I have a first degree term, so I'm going to put 2 lines under it. I have my constant term, so I'm going to put 3 little lines underneath it. And now I'm going to start to add it up. So in adding it up, it looks like I have negative 3x to the second. Let's cross those out. And then I'm going to have plus 1x, or just x. And then I have 3 minus 6, which is minus 3. And there it is. Now let's see if we can uncover this and see if we did it right. And look at that, we did it right. Okay, for this example, this is an application type of problem, and what it says here, let's read it together. It says the cost of manufacturing a certain product can be approximated by this polynomial. Now, what type of polynomial is it? Well, is it in standard form? Yes, it's a third degree, and I have 3 terms, so it's called what? If you said a third degree trinomial, you are right. Where x is the number of units, okay, so each of these x's is the number of units of the product in hundreds. Now, evaluate what is f of 0. So if x is the number of units, in other words, I do 0 of them, I want to evaluate and find what is f of 0, okay? Now remember, f of 0 is what? The cost of manufacturing a certain product. In other words, if I make 0 of these, what is my cost? Okay? All right, so let's go ahead and uncover this. So I'm going to plug 0 in for x, and if I plug 0 into the function here for x, let me uncover each one of these. I'm plugging 0 in for x for each one of these, and then we're going to simplify. I end up with 45. So the cost is 45. Okay, now, in this situation, it doesn't say 45 what? Well, we don't know, okay? I'm assuming it's $45, okay? Now, let's go on. And, okay, so let's take a look at what is if we make 200 of them. Well, I'm going to plug 200 in for x, and, okay, let me uncover each one of these, and then we're going to crunch this out. And notice now we make 23,996,445. Now, if that's in dollars, wow, that's a lot of money. Okay, so now you want to write your answer like this. So here's what your answer is going to come out. It says for f of 0 presents the initial cost before manufacturing any products. Okay, and what does f of 200 mean? It means f of 200 represents the cost of manufacturing 20,000 units of the product. So in other words, it's going to cost $45, whatever it is, $45, whatever it is, to make 0 of them, and it's going to cost this much, 23,996,445, to make 200 of them. Okay, let's take a little bit of brain break. Now, as you're taking a little brain break, you need to get your iOS device or your Android device or your Windows Phone device, and you need to download a graphing calculator. Now, on the iOS, you should have already had this down. It's called the Good Grapher. So if you've deleted it from your device, make sure you re-download it. On your Android device, it's called our Graphing Calculator. Now, if you have a Windows phone, I don't know what it's called. You're going to have to do some searching for a Good Graphing Calculator. Okay, so download those and then move on to the next screen because we're going to do a couple graphs. Oh, and by the way, if you don't have a device, remember, there's a link on the class's website. So go on to SharePoint, and you can use the graphing calculator on the computer. Okay, so I want you to take your device, and you're going to plug in this in for your function, in the graphing part of it. Now, when you graph it, we're going to see just what that looks like. Okay, so pause it and go ahead and graph it. Okay, now that you graphed it, your graph should look like what mine looks like right here. Okay, now they're asking you, not only are you to graph it, but they also want you to describe the graph and identify the number of real zeros. Okay, so that's what we're going to do here. So go ahead and take a look here. And now, remember here, this was quadrant number 1. This is quadrant number 2. This was quadrant number 3. And this is quadrant number 4. Okay, so in a Cartesian coordinate plane, it's been a long time since maybe you've taken a look at the quadrants and how they're numbered. So, I see that this graph comes in which quadrant? Well, this one right here. So I'm going to say it enters the third quadrant, and then notice it leaves which quadrant? Well, I'm going to say it leaves the first quadrant. Okay? Now, notice what happens right here. How many times does it cross? Well, 1, 2, 3. Okay, so you want to say that. You're going to say it has how many zeros? It has 3 real zeros. Okay, all right. Now, go ahead. Let's go to the second one here. All right, go ahead in your device, plug that into your graphing calculator. So go ahead and pause it, and plug it in, and then we'll look to see what it looks like. Okay, now that you've done that, let's uncover this. Your graph should look like that one. Okay, so what does it do in this case? Well, I see it enters which quadrant? Well, remember it's 1, 2, 3, and then 4. So it enters which quadrant? Well, it enters in the third quadrant. And it leaves in what quadrant? Yeah, see, it enters here, because we always go from left to right, and it leaves in the fourth quadrant. And how many times does it cross? Well, once there, 2, 3, 4. So that means it has 4 real zeros. Okay, folks, well, that's going to give us a wrap for today. Now, this page 410 is in section 6.1 of your textbook, so we're doing chapter 6.1 in your textbook. Now, we're going to do 19 through 35, and that is all. And then we're going to do 64 to 72, all as well. Okay, so that's our assignment that we're going to be working on in class next class period. Well, folks, that is all. I will see you in class.